All right. Hey, everyone. Miss Brown again. This is Unit 7, Lesson 4. Okay. This is, we're going to talk about, we're going to explore some quadratics in the real world setting. Okay. This is some real world stuff. And so you're going to run into some word problems and you need to know how to decipher them. Okay. So let's talk about this problem situation. All right. So we have the firing of a Revolutionary War cannon. It's used to open up the local 4th of July festivities. The muzzle of the cannon barrel is 6 feet above the ground. The height of the cannonball being fired from the Revolutionary War cannon as a function of elapsed time is modeled by this function. H of t equals negative 16t squared plus 75t plus 6, where h of t represents the height of the cannonball in feet and t is the time since firing in seconds. So it tells us a bunch of things in here. It tells us that h of t is the height of the cannonball at any point as it's traveling here in this in this parabola, right? And t is the time ever since it's been fired. Okay, all right. So the first thing that we want to do is we want to use these words. We want to use quadratic, parabola, and negative to describe this problem situation. Okay, so I'm just going to type here because I can type quicker than I can write. All right, let's see. All right, so we're going to do this. Oh gosh. I'm going to put this little bit right there. There we go. All right, so we're going to say the equation given represents a quadratic, there's one of the words, function. We know it is a negative function because the squared term has a negative 16. The path, the parabola, there's another word. The path, so the cannonball takes is the shape of a parabola. There we go. All right, so move this around just a little bit so we can see all of it pretty good. All right, so let's see, what are the words that we need to underline? So we have quadratic, let's underline that. We had to use the word negative, so there's that one, and we had to use the word parabola. All right, so those are the things that are important here, okay? All right. So what we need to know, there's a few things they want to know. They want to know what is the height of the cannonball when it hits the ground. So what do you think the height of the cannonball is when it hits the ground? How far off of the ground is it going to be when it hits the ground? Think long and hard. How many feet off of the ground is it going to be when it hits the ground? It's going to be 0 feet, y'all. Most everyone gets that one right. That's great. Okay. A lot of people just think for a long time for that one, but it's okay. All right. So here's the one that we have to think about. When does the cannonball hit the ground? Okay, so we're looking at our picture right here. Okay, so it's fired, it goes up in the air, and then it's right here. So if we think about this, okay, our t is the time since firing in seconds. So this is on the inside of our equation. That's our x-axis, right? So this is really our t, and our y is our h of t. This is our height, right? Look at this. This looks like the height to me. The t is our time. So when does the cannonball hit the ground? So this is when it hits the ground right over here, right? What is that called? That's our 0, isn't it? Okay, so let's go into our calculator and see if we can put that in our calculator, okay? So I have this written down somewhere, so I'm just going to go to my calculator screen, and let's let me expand this a little bit, okay? See if I can make this a little bit bigger. All right, so you can just see what's on my screen. Escape. Make it, it's just, ah. Oh, well, I'm gonna have to pause this so I fix this. Oh, y'all hear my dog in the background. Well, here we go. Okay. Oh my gosh. If they start again, just ignore them. Those are my dogs. All right, so we're going to graph this negative 16. We can't graph a t, but we can graph it as an x. So it's negative 16x squared plus 75x plus 6, right? Okay, so we're going to graph that. And it looks like it's really, really tall, right? And it is. So what I want to know is where this, if I'm looking at this over here, where this cannonball is, let me move this over for a second. All right, now let's look at this. Let me move my calculator over here. These are kind of the same, right? This is where it starts up here, and this is, where it ends. So I want to know what this is. So I want to analyze this. Menu, analyze graph. 0 is what I want to know. Where does it hit the ground? And that x value is where it hits the ground, right? It's at 0 feet right there, right? So it hits the ground at 4.77 seconds, right? Good. Okay, so we know that the cannonball hits the ground at 4.77 seconds. Okay, and I always think about the movie Sweet Home Alabama whenever I see this problem. But so we need to discuss the domain. Okay, let's talk about the domain. Now we know that domain is our x values, right? Right. All right, so let's talk about that. We need to write a verbal description and represent it algebraically. Okay, so let's write a verbal description first. Okay. Okay, so when is it fired? At what time is it fired? Okay, at 0 seconds. 0 seconds is the time when the cannonball is fired. And when does it land? 4.77 seconds is the time when the cannonball hits the ground. Okay, so what that does is it takes into account every single bit of time that the cannonball is in the air. So that is our domain, right? Think about that. That is our domain. All right, so if we think that way, we can write that algebraically. Okay, so now I'm going to pick up my pen and write that algebraically. All right, so we have the smallest amount is 0. Our biggest is 4.77, right? All right, now does it include 0? Well, yeah. So we have it's going to be less than or equal to, and then 4.77, yes, it includes that. Now, we don't have x in this situation. We have a t, right? So our t is going to go in the middle. All right. All right, so now we have to determine the maximum height that the cannonball will go. You know what? What's great is our calculator is going to help us with that too. All right, so here's what we're going to do. Let's go back to our calculator. I want the maximum height. Let's analyze this graph and see if we can see anything there. Remember, we can hit buttons on here. I have yet to see a calculator blow up when you hit buttons. Escape works great whenever you get somewhere and you don't know what to do there. So we're going to hit menu. We're going to hit analyze graph. Let's see, and we're looking for the maximum height. Do you see a word there that says maximum? That's the one I would use. Maximum. Okay, so when you're looking for the maximum, what you're looking for is the very top part of that graph. So you have to include the entire part. So you want to click on the left, you want to go all the way across the entire graph so it takes into account that maximum. So what that does is it gives you a point. It gives you an x value and a y value. Remember, in this situation, the x value is the time. The y value is the height, right? Okay, so they want to know the maximum height. What is the maximum height? Well, it's 93.9 feet, right? It's 93.9 feet, according to our calculator, right? That's how high up the cannonball went. Okay, and then if we look back at our calculator again, it actually tells us at what time, how many seconds it took for it to get to that 93.9 feet. How many seconds was that? What does it say? What is our x value at 93.9 feet? It's 2.34 seconds, isn't it? Well, that's our answer to that. So it took 2.34 seconds for the cannonball to reach its maximum height. Guys, this is the kind of information that sports analysts use to make athletes even better. Promise you it is. All right. So this is it for Exploring Quadratics. You have Unit 7 review. There's not a whole lot. There's not really a video that goes with that one. You just have your Unit 7 review. Okay? All right. Have a great day.